Alright, number 34, find the first and last position of an element in a sorted array. So I haven't looked at this one at all yet, but given an array of integers nums that is sorted in ascending order, find the starting and end position of a given target value. If a target is not found in the array, return -1, -1. Automatically I see O of log n, and well, it's a sorted array, so you could, like, honestly, I think you could just do a binary search here, and then once you've found the target, you just increase the pointer by 1 until you get to the end, and decrease a pointer by 1 until you get to the start. Because the naive approach here honestly looks like you would do, let me pull up Paint. So what it looks like it would be easy to do is just take this. You just have an array with a pointer that starts here, and you just increment by like a -1 until you find it, and a +1 until you find it. But that's an O of n solution, and we need an O of log n solution. But while I look at this, I realize you could also do this solution, and then whenever one finds it, you could just break from the loop with this pointer, and then iterate out until you find this. So what I mean is, we initialize a pointer at each end, go in one, oh, we found it with our right, bring our left pointer over here, and then decrement that until we find one that isn't equal to 8, add 1, and then we have our 3 and 4. However, I think that's still not a great solution. I think the binary search is a better solution. So, how does a binary search work? I'm not great at these questions, but you need a low pointer and you need a high pointer, but we'll just call it L and R, which is equal to 0 for our low. Our R is equal to the length of our list, nums, -1, because we're using a right pointer. So we need the -1, and that takes us to the end of our list. Okay. So the way that a binary search works is you do while left is less than or equal to R, mid is equal to L plus R, in brackets, floor divided by 2. This will give us our middle index. Then you do if nums mid is less than the target, so in our case, just call it nums mid is 7, L is then equal to mid plus 1. Make this an elif. Elif nums mid is greater than the target. We're going to get an else here. We do R is equal to mid -1. And then we want our if nums mid is equal to target. What do we do here? We return mid, or in this case we do found is equal to mid, while L is less than or equal to R, or found does not equal -1. So this is two stopping conditions that we're using when we've either found it or while left is less than or equal to right. Then down here, okay. So if it's found, it'll break, or if left is less than or equal to right. So we can do if found is equal to -1, means we haven't found our target number. So what we can do is just return -1, -1. Else we have found our target number. Means we're here. Okay, so how are we going to do this? We've got a index number, which is, if we put nums found in, we're going to get our target. So we need to do, I'm going to do a poor solution here just because I think it would be good to just get this working, because this is getting relatively long. So we can do while x so we have found, okay, wait, I'm going to pull back up our paint. So right now we've found our target, which our target index, which is found equals 0, 1, 2, 3. And we have while x, so we can do low high equals false false. This will be to indicate that we have not found our lower number and we have not found our higher number yet. So while x, if low equals false, what do? We do, if low equals false, we can do if L index, H index, both equal to found. If low equals false, we can do if noms L index -1 equals target. L index equals equals 1. Else, if it doesn't equal to the target, low equals true. Then we have elif. No, we don't have elif. We have if high equals false. What do we do? If noms index +1 equals target, we do the same thing here. And then we need to change this to while low equals false and high equals false. And then when we break, we return L index, H index. 0, 1, 2, 3, 4. Yeah, I like that. I think I like that. So we can get rid of this while X, and we can do while low equals false and high equals false. Then we do if low equals false, if nums lindex minus 1 equals target lindex minus equals 1, else it doesn't equal target, so we set low equal to true. Then we do if high equals false, if nums index plus 1 equals the target, we can do index plus 1 else high equals true. Then we can just return found lindex index. Okay, I like this solution. I think it should work. If it doesn't work, I will have to take a look at the answer because I like this solution. I think combining a binary search with this method will probably be faster on like way bigger arrays. Obviously the 2-pointer method I think would work well. Time limit exceeded, that's not good. That is not good at all. Why would that not be working? Alright, I'm going to take this into Gemini and see what I'm doing wrong here. Why is this TLE? Would this solution scale well to high array lengths? The iterative expansion after finding the initial occurrence can lead to performance issues for very large arrays. Right, so I think mine, I don't know why why would it time limit exceed for this? I want to open VS Code and see if my solution works, because I actually thought it was pretty good, but clearly it's not. New file. Okay, let me take my code and noms. Okay. Dot search range noms 8. It's from typing import list. What's it missing? Target. You mean it's missing target? I need self. Can I get rid of self? So if I got stuck in an infinite loop here somewhere, I feel like I might have got stuck in an infinite loop. I'm thinking I definitely got stuck in an infinite loop. Alright. If high equals false, if it equals a target, add 1, else set it to true, else set load to true. Is only once the code will correctly find the target is found. When it enters the while loop, it will try to expand the range both to the left and right. Since the target only appears once, both will be different from. This means that low and high will both become true. Becomes true equals false and true, which is false. This terminates, but the range hasn't been properly determined because the expansion only happened once. Go as long as you're ensuring that. No, that's not right. That's not right. It has to be an and. I'm gonna change it. I don't believe that this will fix it though. I was right. So what is causing an infinite loop? I might add some print statements in here. Alright, I found the issue. So it's getting stuck in an infinite loop when it finds mid. Why it's doing that, I'm not sure. If nums mid equals target found equals mid print found. Like this should be breaking. I can try adding a break statement. I just don't know why it makes a difference. Because found is getting set to something that doesn't equal 1. That's really strange to me. List index out of range. Right, so it's trying to... If high index plus 1 is equal to the len of nums, what we can do is, I think we can just set high is equal to high equals true, and if lindex minus 1 is equal to 0, we can set low is equal to true. I don't understand why I needed to add a break here. Low equals false. Damn, Gemini sucks. What did they do to my boy? This new model sucks. Oh, so close. Okay, why has it done this? So we've got low index, high index is equal to found. Which is obviously going to be 0. Then we've got if it's minus 1 is equal to 0, then set low to true, and then if it, so it should just skip right over. Oof, so close. 0 to, okay, so there's still something wrong with this. Maybe I need to move this below and do a check here. But without the 1. Okay, so what's happening is index should equal to 1, minus 1 is... Why is it doing that? The target is 0. So let's print L index. Let's see. So it starts at index 2. We loop through once. It gets knocked down to 1. Go through another loop. 1 minus 1 equals minus 1. Nope. Does index 1 minus 1 equals target? Yes. But it's not working. Okay, so it's getting set to true after this. Presumably on this loop here, where it should not be getting low set true. What? How is this happening? Huh? Huh? How is it what? While low is false and high is false, how could it have ever returned out? If it's... What? That's not possible. It's impossible for this loop to end if low equals false. Well, low, maybe it's, oh, it's meant to be an or. No. Or high equals false. Yeah, okay. Oh my goodness, that was giving me a headache. Yes! Oh, cool. That end really had me confused there for a moment. Yeah, I think that all makes sense. I like the solution. I like it a lot, combining a binary search with this afterwards just to find it. I think that's a good solution. Even if it took a little bit to get there. But yeah, cool. Not as easy as I thought it would be at all, but I like it.